Hello everyone, my name is Jonathan Robles and today I'm going to talk about our research that is called correlation between electronic factors and fracto-triboluminiscence in complex type M p ligands. Okay, so to start, well, in this study we want to analyze the phenomena of fracto-triboluminiscence because can have different kind of applications for example engineer applications. Okay. And well, to introduction, well, fracto-triboluminiscence is a type of luminescence generated by the creation of new surfaces during the fracture of solid materials. So for these reasons we want to study because, well, this could be applied in some walls or in construction, for example. And well, we want to make a experimental study and theoretical study. And well, the methodology that we follow was the next. For the synthesis of the complexes, we can see in the left side what we do to obtain these complexes to study. For example, for copper, we made a reaction mixture of N moles of copper thiocyanate, N moles of pyridine, and N moles of triphenylphosphine was prepared with heating at 70 Celsius grades for 3 hours. And well, after the synthesis, the reaction mixture was allowed to cool to room temperature, leading to precipitation of the complex. Okay, well, this is for the copper. During the solvent evaporation process, well, we obtain the crystals that we want to work. Okay, so the other kind of, well, for the other complex, the silver complex was the same. This is interesting because this characterization allows us to obtain these two complexes to study. And in the theoretical part, we use density functional theory analysis. We made a study using the PV functional and the B3-lip functional in order to make a comparison between the results, and we want to obtain the minimum value of energy and the structure with the minimum value of this energy. So for this case, we use the base def2t CVP, and to obtain a theoretical UVVs or UVVs spectra, we use time-dependent density functional theory, and we use the same functional on the same basis. With this, we want to obtain the configuration of minimum energy and to obtain the orbitals HOMO and LUMO of the complexes. So for the results, we have the next, as we can see in the scheme 2 and the scheme 3, and well, we have the next. We made a FTIR characterization of the complexes in order to know, well, how are these complex in general. And well, we can see in the both complexes we have an oxidation state of +1. Okay. And well, we want to know if this is how is going to be the phenomena if we change copper with silver. We want to make a comparison between these two complexes, and we can see that for both infrared spectra, the characterization bands appear around of 2050 and 2100 wave number. Okay, this is important. And well, along with two intense bands at 740 wave number. Okay, and from the isothiocyanate ligand, this is because the isothiocyanate ligand. Additionally, it's important to mention that a weak band associated with a pyridine stretching vibration at 1590 wave number for the wave number. And well, appears another two intense bands at 1430 and 1470 due to the presence of triphenylphosphine, as we can see in these compounds. Okay, well, this is important because this was the result of the infrared spectra, and we too do a UV-Vis characterization of both materials, as we can see in the scheme 3 and the scheme 4, obtaining that, well, the maximum for copper is in 350, and for silver 1 was in 320. And well, these results was well, we make a comparison with these results with the theoretical part, as we can see in the right side in the scheme 6. In this case, we obtain with time-dependent density functional theory the UV-Vis spectra in order to characterize the absorption of this complex. And well, as we can see, the results are similar, but well, have some difference. This could be for the simulation, for the parameters that was used. But another thing that is important that we can see is that we obtain the transition orbitals. We can see what are the transition orbitals. For example, for copper is from HOMO-3 to LUMO. And well, the UV-Vis density functional obtained by density functional theory, time-dependent density functional theory for silver, was from HOMO-2 to LUMO+1. And well, with this we obtain the transition orbitals, and we obtain too the force of the oscillator for two complexes and the weight of the function, well, the function that describes the orbitals, and finally the energy between these two, well, in this transition that was made in this transition. Okay, so well, this was obtained for the theoretical part, and as we can see in the scheme 6, we can see the HOMO and LUMO orbitals obtained by each one of the complexes for the copper complex and the silver complex, and how are distributed. This is really interesting because we want to know which bond is going to break, if we apply some forces. And in both complexes we have that isothiocyanate have the HOMO orbitals, and well, we can conclude that if we apply a force in this complex, well, the bond that is going to break is the bond with the isothiocyanate, because have the HOMO orbitals, so is easier than lose electrons. And well, for this reason, maybe we can conclude, for this reason we can conclude that this bond is going to break. And it's interesting too that, well, we can see the orbitals LUMO for the both complexes that are and how are distributed. Okay, well, this is interesting in order to characterize the complexes, and we want to know how is the behavior, because we want to propose as a future perspective another kind of ligands in order to improve this behavior and the phenomena of the fracto-triboluminiscence. As a future perspective, now that we know what is the bond that is going to break, where are the orbitals distributed, we want to propose another ligands that allow us to have the same phenomena, but that are more easy to work and that have no secondary effects. Okay, so for that reason we want to make a study of this. And well, as a conclusions of this work, we have the next. The principal electronic parameters characteristic of a fracto-triboluminescent complex were obtained and compared with experimental results, and we have that, well, these results are similar, and we can conclude that the experiment was made with a good technique. These findings will inform future proposals for new structures with similar requirements to optimize the triboluminescent effect, as I mentioned before. The second one is the HOMO orbitals of each complex were found to be oriented over the isothiocyanate and metal bonds, which may help predict the most likely location for bond breakage between the central ion and the ligands. And finally, well, the reduced triboluminescent effect observed in the silver 1 system suggests that the crystalline structure of the complex is a crucial factor in the fracto-triboluminescent effect. Despite having similar electronic factors to the copper 1 system, the difference in the crystalline environment play a significant role. This means that, well, these complexes have similar structure, and both are silver 1 and copper 1, but the difference of the behaviors is because the crystalline environment. So for that reason is a significant role, because this crystalline structure is going to produce different results for both complexes. And well, that's it. Thank you so much.